Unit 13.4, traversing arrays. Here are all the methods I'm going to write. I have them stubbed out already below, but let's take a look. Some preconditions. A must be less than B. The row and column value or index do exist. So what we're going to do is populate a two-dimensional array with random values on an interval A to B. Find the sum of all the elements in a particular row, the sum of all the elements in a particular column, sum of all the elements in the entire thing, and the average of all the elements in the entire thing, the entire 2D array. So populate. Oh, by the way, we're going to do all this at once. Okay, we're going to do the population. Then we're going to find a specific sum in some row here and a specific sum in some column based on the populated one. And then we're going to find the average of all the elements. I shouldn't say that. We should find the sum first and then the average. Moving down where the methods are all stubbed out, and we're going to just jump in. First one, generate a two-dimensional array. Well, first of all, I have to make one. So int a, I'm just going to use a, equals to a new int. All right. What will be the size of this? Well, let's say it's going to be an int row, int column. You're going to tell me the rows and column, and I'm going to put it in as row column. You tell me the size, and then I'm going to populate it with some random numbers. Let me write the random number generator. How about that? Gen new random. Remember, we could use math.random also. I just don't like using it because it's easier to write this one for me. Math.random for me is a lot more typing. Oh, here we go. Row major order. Row major order. So we have the column coming in here, so I can't use column and row here. So you know what I'm going to write it as? Uppercase row and uppercase column. All right, just so I could have some definition here as to which one I'm using here. So I'm going to get rid of this because I'm not printing. I just borrowed this code. I now want my row major order. And I'm going to have to return the array when I'm done. So let's just return A. Okay, so right now, this method is almost finished. Now you realize how the setup looks here. Okay, I created the array. It has all zeros in there. I made a random number generator. It's going to generate some random numbers. All right, we know the size of the array, but we didn't put in the A and the B in our method. So let's put that in, because we got to generate them based on A and B. Oh, we're going to have a confusion here. So I'm going to call my array array. That's okay. I'm just going to change it to array. And that's one of the reasons why you need to organize your stuff before you start. So I should have already had my values in there, but I'm building it. So as I'm thinking, I'm building. So I have how many rows, how many columns. You know what? I'm going to actually change this back. I'm going to call this rows and columns with an S because I don't like this uppercase here. And this is going to be the actual row and column like we usually have, the row major order. So it looks good. And I like to keep things the same. So that way I don't have to worry about the changes and stuff like that. So this is going to be rows and columns. That's how many we have. That's the dimension. So you can see my row major order all set up. And what I'm going to do now is just fill it up and say, hey, array, in position row and column, generate a random number. So it's next int, next int. I'm going to look for that and just put the semicolon here. And now I'm going to think about it. Remember the formula? Let's see if we remember. Let's see if we remember what goes in here. B plus 1. No, that's the mistake we made before. It's not going to be B plus 1. It's going to be B minus A plus 1. So right now I just generated random numbers in this particular interval, and I've created the array. I put the values in and I sent it back. Moving on, sum of the row. So the row exists. That's the precondition. So let me write the precondition. Maybe I should just put it here. Row exists. So we don't have any outer bounds here. And the column as well exists. So we're going to have that as something we need to pay attention to. So in this case, we don't need a nested loop. We just need one, because if we know the row, all we need to do is make sure we have the column. So it's a dot a row a 0 dot length, and then column plus plus. Why am I doing column? Because the column is where we're going to go for each row. We want to find out the particular column for any row you tell me, because that's not going to change. So I'm going to again then say a row column. See that? Because I want the row is not going to change. The column will change though. So column going to start at 0 and column is going to keep going. And I want a sum variable, and that sum variable is what's going to get updated here, right? So every time, so this row is fixed, okay? So for that particular row, but we're going to go across every value in the column, so we're going to add up every single thing in the row. And then when we finish, we're going to return it, okay? Return the sum. So when the sum comes back, this is the sum of all the values in this specific row. Same is true for column, right? I'm going to do the same thing down here for column. I'm going to copy and just borrow the code. I'm going to use the same sum, but this time the column is fixed, right? So I'm going to go ahead and change this to row, because now I'm going to go down. You see, going down the column means increasing in the row. And because I increase in the row, I now have every value in the column. Remember, row is still first, okay? Row is still first, and column is second. So if I have the particular column, that number is going to be fixed, and then every row now is going to be row 0, then row 1, then row 2. You can see me going down the column. I'll get the sum and I would send it back. Now I want to find the sum of all the elements. Well, I could use either this guy or this guy, right? Because I could figure out how many rows do I have and call this to sum every row. So let me go ahead and write that. For int row equals 0, row less than a dot length, row plus plus, and then we're gonna do this sum now. So I gotta make a sum variable, int sum, starting off at 0, and then I'm going to add every single row to this sum, plus equals, and I'm gonna say sum the rows. And now I'm going to put in the row, and I'm going to put in A. You see what I'm doing here? So what I'm doing here then is I'm finding the sum of all the elements, okay? A couple of things here I didn't mention. This is a non-static method, but all the others are going to be static methods, okay? So you see how I have a bunch of static methods? I have to introduce some non-static methods. So what I'm doing is I'm writing the sum row using that sum row to create the sum of all the elements. And for doing that, what I'm doing is I'm calling each row, taking that value and summing it and adding it to the sum. Then when I'm done, I return the sum. So now this should get me the sum of all the elements in the array. So I'm doing it row by row. So you could tell that every time this runs, it's going to jump up here and then add up that particular row. So for the first time, row is going to be 0, right? It's going to pass a 0 up here. It's going to do the 0 row, send back the answer, add it on. Then row plus plus. Going to go up here, do row 1, and so on. Now it's time for the average. But this time, because of average being a double, and I have an int there, don't want an int, want a double, I'm going to go double for the sum and make that 0.0. But now I'm going to do the same thing like I did before. Instead of calling the array sum up here, the row sum, I'm going to call the find sum, right? So it's going to find the sum of all the elements. So why don't I just put it right here? Well, let me do it at the bottom. It doesn't matter. Sum gonna be equal to find the sum. This time I'm going to put in the array. So what I did is I'm showing you you can write methods by using methods that you already wrote. These become what is known as helpers. See, this method helps this one. Because when he finds the sum, then all I got to do is return the sum divided by the length. But the length of the array, remember, is going to be a dot length times a zero dot length. Right, remember how 2D array work. Can't just do a dot length like in the 1D array, because in the 1D array, if I just do a dot length, what would happen is it would just get me, in this case, the how many rows there are. I need to do times the number of columns to find how many I have in all cells. There you have it. We have all the methods, so we're going to go up to the main and run them, and then we wrap it up. So let me just run up to the main here. So populating this guy, so I'm going to make an array. I'm going to call this values. It's going to be 2D array, and I'm going to say unit 13 dot generate this 2D array. I'm going to make it a, for ease, let's stick with, I'll go with a 4x4. I'm leaving it nice and square. Let's, so numbers between 10 and 30 are included. Since I did that, let me print it. How about that? I'm going to say unit 13.print, right? And it's going to print values. Every time I do it, I'm going to print. So let's get the sum for the particular row. I'm going to say system.out.println. I'm going to say unit 13. This is a static method dot sum row. And I'm going to do the row 0. And I'm going to make values my array. Okay, so I did that. Now I got to print this one. System.out.println and unit 13. These were all static. And I'm going to do some column. And this time I'm going to pass in column, let's go column 1. And it's values. So we're going to look at all these and see if they're right. That's what we want to make sure. And then the sum of all the elements, the system.out.println. This one was not static, right? So I need to create an object. Unit 13 object equals to a new unit 13 object. And then I could ask this object to find the sum. So object.sum. Okay, so we're looking for finding the sum, and its values is the name of the array. And then finally, I have another one down here. Let's just borrow this rather than typing it up. And now I'm not going to do the sum. I want the average. So let's delete this and then write it over. I like when the code completion does it for me. Find the average and its values. So right now we have a bunch of things that we just wrote, and we're going to run this and see if they all work. If they all work, we're good. But if they don't, then we make our changes. Let's run it. All right, so here we go. This is the array here. All right, let me just put a space in between so that we could differentiate between these two set of prints. So let's system out.println for a new line, and let's run it and see again. Okay, so we have this random array generated. It's a 4x4, and let's see what we did. We did a 4x4. We did numbers between 10 and 30. Then we did the sum of all the values in the 0 row. So 21, 26, 17, and 11. I'm going to get a calculator. I'm not going to do that in my head. 21 plus 26 plus 17 plus 11. 75. Correct. Then we did the sum, column 1, which is this guy, 26, 10, 17, and 11. Let's see if that's right. 26 plus 10 plus 17 plus 11. All right, 64, that's good. Then we did, after that, we did the sum in a specific, the sum of the specific row we did, sum of specific column we did, and then we did define the sum, which is all the elements here. So, yep, let's go ahead and add them up. 21 plus 26 plus 17 plus 11, 23 and 10, and then 15, just to make sure it works, 28. And then we also have 11 and then 17 and 18 and 25. So far so good. Then 27, 11 again, and then 29, and then 23. Is it good? Is it good? 312. Perfect. Now we got to get the average, right? Which is this sum divided by 16, because remember it was 4 by 4, 19.5. All right, if we run it again, we'll get probably a different set of numbers because it's randomly generated. But from that little exercise, we could see that it works. Okay, so that is traversing 2D arrays. Let's recap really quickly. When you traverse 2D arrays, you have to write loops. You have to write row major order loops. That's the way we're going to do it. So row on the outside, column on the inside. And when you're working with the array, the row is always first. Keep that in your mind. The row is always first. If you're adding up all the values in a particular row, you'll need one loop. If you're adding up all in a particular column, you only need one loop because that particular column value is going to stay static. Let's say this is column 1, it's going to always be a 1. This was row 0, it's going to always be a 0. Finding the sum, it's nice to do these methods up here because you could use them. I could have used the sum of the column as well here to find the sum. I would just be doing columns and call this guy, give it the same answer. And average finally is nice because we could use this. So this is what I'm talking about here in terms of helpers. This method needs this method to help it, and then this method needs this method to help it. That's good code. Okay, when you have a method that helps a method who helps another method, it's nice that they are working together. All right, so that brings us to the end of traversing arrays.